from home. Okay, let's move on then. This is actually quite exciting. I'm really looking forward to this. Looking forward to this. So what we're talking about now is we've just finished working with Google Analytics, and hopefully by now you have a respect for kind of like how analytics works, and you can use it for your own websites. You can put it together for your own purposes. I do expect you, though, not that I'm going to make you, but I expect you to use analytics for your own websites here when you're starting your careers. I mean, check to see that people are logging into your website, see how your website's performing, see whether people are clicking on your resume, your projects, all of these things, because it's nice to know that people are clicking on these things. And if they're not clicking on these things, maybe it's because they can't find the links. Maybe maybe you can use this understanding to change the way that your website is laid out so that it's easier. Anyway, you know all this. But Google Analytics, though, is a software which was written by Google for analyzing websites. And it's a software that was written with some kind of purpose in mind. It was like they put this together and said, okay, here you go. This is your software. You take your website, you put it together as software, you fuse them together. And once they're together, then you have this tool. But the trouble is that where we're going now is that we have data, and there may not be a tool that actually works to analyze that data for us. That's a big problem. So why am I saying this? Because we're going to start using rStudio here, the R language, and rStudio to develop some of our own procedures in analysis. We're going to be coding. Now, I know that you might be thinking that I don't have any experience in coding. Don't worry about that. Don't worry about any of that. Well, we will get there together. We will get there together. It's always worked. Everyone, in fact, I've had people I had a student from philosophy just a couple semesters ago. She had never, ever coded a thing in her life. And by the end of the year, she had put R programming on her resume, which was a major high five. That was just terrific. But what I'm saying, though, is that we will get there together. All the programming, don't worry about that part. Don't let that throw you off. Don't let that make you not enjoy this class. This class is open to everybody. So we're going to be using this book here, which is actually, I think, a very good book. This is called R for Data Science here. You have this website, which is right here. And if you were to go to a page here, hopefully you can see this, you can just click on that or drop that link in there, and then you have the book available. It's an open source book. So you can click on seemingly everything here, and you have the chapters, and you have some pieces of code that you can just copy and paste. And so it works out quite well. So I chose this book because I really like this book. But the thing is, though, that the book, I'm not sure exactly how this worked out, but the online version of the book and the paper version of the book are not the same. They're not the same chapters. Now, every time we cover topics from the book here, I'll have this slide here. We have chapter 2, showing that this comes from the book. But if you're using the website here, you can use it's chapter 3 or chapter 4. So for some reason, it's not the same thing here. But so if you're using the book, if you're using the online version, then you know where to find the current pages that we're on. Or if you're using the actual printed version, then you know where to find the chapters that we're looking at. Anyway, so that's just what this is here for. So let's just talk about the programming language here, the R programming language. R is an open source programming language. That means that you don't pay anything to download the software here. And in fact, you can pick it up from this website here. But before you do that, let me just go through some other stuff with you. And then we'll actually take some time here to install some of these things. But let me just talk about what this language is. It's very well developed and it's very well maintained. It's a very good language for doing statistics. And your R programming language, it may not be the language that you would choose to make a really fancy app for your iPhone, but it is a language that you might choose to do some very fancy statistical analyses on things here because it's efficient, it's easy to use. Well, it depends who you ask, I guess, but it's easy to find information about how to use it. But also, though, it has many, many libraries that are built in which enable some very advanced statistics from being calculated. So what I'm saying is that you're able to find kind of sets of instruction available online which will do things that you want to do in your code. That's what I mean by a library. But one of the things I really, really like about this language, though, is it says here that it's a cross-platform language. That means that you could write code on your Mac computer. You can send that code to your colleagues working on Windows machines, and then they can share this code in turn with people who are working on Linux. So it's the same language all around. It's very much like Python. It's the same language everywhere you go. And that means it doesn't matter what hardware you have, you should be able to run this thing here. But also it's very, very big with data analysts here. I mean, people use this to write all kinds of really amazing analyses, and data scientists too. Here are some blogs. I just wanted to put these things up here. If you're bored, for instance, you can always read these things. And toward data science, though, this is one thing I like to read. They tend to have articles in here that talk about using R to do all kinds of interesting little manipulations and things. And so you can always check that out to see what what blows your hair back. You might find that, for instance, there's a really interesting program in there that teaches you about how to how to do some kind of a machine learning thing. In fact, we do have some machine learning examples in this class, which have been inspired by some of the articles that I've read at Toward Data Science here. But anyway, we'll get to that. Now, in terms of the R language here, I could have chosen Python for this class, but I chose R because I'm thinking that if you're in my other classes, you're probably going to learn Python from those courses. But I want you to learn R because R is actually a very important language in the professional world. And so you can see here that this is a graph that's talking about people who are using, or languages which are used for statistical analyses, and R is basically the go-to language. Now, because R is an open source language, that means that anyone can download this program. You don't have to pay for it; it's all free. Because you have that, it really encourages people to collaborate across industries or across universities or campuses or even departments, and that is because you don't have to go in and buy some software to make something work. Now, this is actually a personal story for me, where I was working in a lab, and somebody came up to me, and actually I met them at a conference, and we were talking about some really exciting research. And I said, "Oh, I'd love to help you with that. I'd really love to help you with that program. I mean, can I be a part of your team?" And they said, of course, it'd be great. The more the merrier. Let's do this. And they, so I said, well, send me your code, and I'll see what I can do. And they sent me their code, and the code was in it was an SPSS, which is another statistical programming language. But you have to pay for it. It's not free. And there was no way that I could afford that SPSS. I just couldn't afford that program. And my department at the time didn't have SPSS. Nobody had SPSS. And so there's really nothing left to do. And so I just couldn't work with this person on that particular project because the language was the wrong one. Now, if you have R, that means that, for instance, I'm working with R, and Alex, if you're working with R, then that means that you may not have the program right now on your computer, but you can download it for free, and you've got it, and suddenly we can collaborate. And then Wes, if you wanted to join in here, you can download the software too, and then suddenly we're all working together, and there's no reason why we couldn't come together. So that's why R for this course, so that it will encourage your ability to collaborate with other people without having to worry about software licenses and so on and so forth. But really, though, this is a graph that goes up to 2013, but actually it's about the same kind of, I would argue, about the same kind of, the data is still the same today, and that is that many data mining teams and statistical outfits are looking for people who can use R. A lot of people need R. If you look at jobs, for instance, for data science type positions here, they typically say that you must have some kind of R skill. Most users are satisfied with R. They're saying that in this graph here, they're saying that many people are extremely satisfied. It seems like almost half the users of R are extremely satisfied with how R is working, which is quite exciting. I will say one more thing about R, though, before I move into some of these other things here. These are more programming languages. Let me go back to this over here. Here we are. See this in the middle here, the fourth down? That's SPSS. That's IBM SPSS. And it's a good program. I'm not saying it's bad. It's good statistics and everything. But it tends to be that I just didn't have the I don't know why this thing keeps showing up here, but I just didn't have the license for it. But what I'm going to say, though, is that SPSS, though, as sophisticated as it is, many of the tests are done very automatically. And that means that you put the data in, and then you have a panel, and you click on, I want to do this test, and then this test, and why not? I'll do this, and all these other tests. You just click on all these tests. And while that's fine, and there's no problem with that at all, It's just that you may not develop a real respect for those tests because you haven't had to code those tests yourself. But when you're using R, for instance, there is no clicking like that. You actually have to implement the code to make those tests possible. And then by doing that, you learn those tests inside and outside. And so you know by the end of your code if that test is going to work with your data. There are no surprises. You're not going to be publishing your data. Now, I know it's more difficult up front, but you're not going to be publishing your data only to find out that as you're going to deliver your speech before your colleagues, that actually you got the wrong model, or that the data was wrong, or something didn't connect. The data was wrong for the model, in other words. So you don't have those surprises, whereas you could have them with other things. We just kind of click on different types of models and say, oh yeah, this should be okay. But when you're working with R, though, since you're coding this stuff in, you develop a deep respect for all of your models, and that's a good thing and a bad thing at the same time. This is the 2017 ranking to others. That's basically ranking to other types of programming languages. As you can see, that R is number 6, but still, in computer science, there are literally hundreds of different programming languages. And so I'd say that if your language is in the upper 10, then that's not bad. That shows some real. I mean, it's very hopeful, because if you're at the 300th language here, it's probably not so great, because you're a language that probably deals with a certain type of chipset and nobody really uses it very much. But for the top 10, though, I would say those are more popular. Now, I wanted to take you through, in your sandbox today, I've given you 2 different means of actually running this code that we're going to be working with today here. We'll talk about this, but we're going to be using this program here called rStudio and R. And so I have, in fact, you don't have to run this right now if you don't want to, but you can. It'll take some time, but you can if you want. But I've given you a script, I believe, to actually run R in your in a Docker container. Let me just get to my prompt here, and I can show you what I mean by that. Let's see, here's my prompt. I have to keep resetting this, otherwise I won't see it. Okay, so if I go to my container, let's see, fall, actually 2020, fall, and then we're in 301, class docs, and we have lessons. I should have had a different word for labs here, but whatever. Then we have 03 week, and then if I go there, you should have this directory in here called sandbox. Now this is in your class docs repository. Now when you go in here, and I'll just run this in here because I'm wild and crazy. We won't make any changes here, but you'll find that there are these 2 files here. One is called build run, and the other one's called build run rbase, and the other one's called build run rStudio. Now, we're going to be using rStudio in this course, and so this is a program that you could use to actually run rStudio. There are 2 ways of doing this here. Either you could run it to your container like this, or you can just download the software and install this locally on your machine. But to run this build run, oh gosh, sorry, there we are. So we have these 2 things here. So we have build run. So to run these 2 different things here. I'll just show you what it looks like here. If I type in build run rStudio here, I can type in my password. Then it's going to do all this crazy stuff, and that basically just says that I'm setting up the container. Now, if you run this on your machine, to run the container, this is presuming that you have your Docker containers working fine. Then you'll have all this code that kind of comes through the screen here, and the screen is going to, it's basically building, your container here. But now my container is built here, so let's see what else we have going on here. So this is what it should look like. This actually, when you go back to it should look like this here. But before I could do that, though, I have to go back and I have to find out. I have to copy this URL. And then I have to go back to my my browser, and I have to paste it in there. There we go. So it's going to look like this. This is running everything right out of the container here. Now you're probably wondering, what do I put here? This is rStudio, and the password. Well, actually, the password. Let me just take you back here for a second here. I've actually written out what these things are. your password is, in the code, I just put let me in. That's what your password is supposed to be. And your login is supposed to be rStudio. The green code here is not that doesn't come from Docker, that comes from your script that I wrote. But hopefully that'll help you to kind of determine or infer the good stuff from the just other noise from the machine here. Okay, so when you log in here, you'll get this. This is what your rStudio is going to look like. So actually, it's quite exciting here. I mean, I will say it's quite exciting here because this is where you're going to be writing your code. Over here, this is where you'll see your. You can't really see what I'm talking over here, but over here, for instance, in the upper right, that's where you're going to be seeing all the variables that you declare, which is actually quite nice because if you're running some kind of statistical analysis here and you're declaring you have 10 or 15 different variables that you're using to kind of orchestrate your analysis, you can keep track of all those variables and how they're changing and what their values are up in the global environment. I think that as we start using this, you'll see you'll see the value of that. And then down here, you can have some idea. In the lower right here, you have your files that you're using. You have your plots. If you make some plots and some other things here, and some help here. So before we get too involved in this thing, let's go back to the slides for a second here and see what else we can muster. Now, in your slides, hopefully you can see them here. In your slides here, everything I've just told you about the login, it's all here too. In fact, if you look at this right here, this is the actual piece of code, if you will, that actually launches or actually builds and then launches your container. You may have to run this twice. I had to run this twice if I didn't have the script here. The first time I ran this script, or the first time I ran this piece of code here, which essentially says to build a container and then inside that container to place the rStudio code and then allow you to run it. The first time I ran this thing, it just built the container, but it didn't actually run it. Then I ran it again, and then it allowed me to actually go in there. Now, don't forget, though, that once you have run this thing here, you have to go into your browser to actually interact with this. Now, let me just tell you something here. The reason why I like this container is because everything that we use in this class, all the libraries, are updated fairly regularly. They're fairly regularly updated, and I don't see why they have to be updated so quickly or so often, but they are. And it seems that when you use a Docker container like this, where every time you run this thing, then it's checking to make sure that all the libraries that you have in your machine for this Docker container running rStudio, making sure that all those libraries are completely up to date and the most current as possible. Then it means that you're able to kind of keep up with rStudio. Now, if you were to install rStudio and keep it locally, then you have to do that maintenance on your own. And while that's okay, I do find that still at the rStudio download group, whoever they are, you don't always have access to the most recent libraries. For some reason, they just don't make them available. And in fact, there's I think it's every couple of months, then they finally give you all the libraries, but you have these intervals where you have to wait for those updates to come. And so that does happen. And so if, for instance, I don't expect you to use rStudio in Docker. You can compute the way you want. But I'm saying that you may find, and as I found over the summertime here when I was preparing for this course, that some of the code that we were putting together, some of it, did not work as expected when I was using the downloaded version of Docker. And so now you have this backup, if you need this, to run your rStudio code here. And so I'm thinking that this should solve everything, right? But I think that for me, though, I'm going to probably spend a lot of time using a local install of rStudio, and that is just because I use this so often, I don't see the reason why I should always run this in a container. But if I find that my Studio local install, does not have the necessary libraries, then I'm right back and using this, and this works just fine. So I'm not trying to tell you how to compute here. That's not what I'm trying to do here at all. But you have now two options. You have the rStudio that you can run in a Docker container, or you can follow this advice over here, and you can install this locally and have your rStudio on your own machine here. But the one thing about this is that if you're installing a local version of rStudio, then you have to install the R programming language at the same time. Actually, I install that first, and then install rStudio. So below you have the two links on making that happen here. This link down here is going to be for the programming language. Remember that RStudio is a kind of an editor. It's a very sophisticated editor, but it's an editor nonetheless. It doesn't actually have the programming built into it. The programming language here, that has to come from this link here. So you install R programming, the R programming language here, and then on top of that, you install RStudio, and then RStudio should be able to connect with R statistic, and then it should work just fine. But if you're using this R or this container over here, and you just run the script that I gave you, then everything is installed at once automatically for you, and so you don't have to worry about anything. And so it's actually very nice. Anyway, I will let you spend some time actually playing with these things here. Please do. I mean, do try and install this RStudio on your Docker container. I mean, I can't say enough good things about Docker, and that's because in industry they use Docker all the time. And I want you to become proficient at this. And also in this class, we do it from time to time. We use Docker to run Gator Grader. I'm not sure if you know what Gator Grader is, but basically Gator Grader is this tool that we use that makes grading for me very, very simple by ensuring that all the pieces that you're submitting for your homework are actually all together. They're all there. Nothing's missing. Okay, so if you find that you just need to learn, you're working with R, and maybe you're using your iPad or you're using some other tool that you have no keyboard and you just want to like do something quickly, well, you can always play around with this jdoodle.com execute R online link here, which is actually quite cool. It's actually quite a cool thing. But actually, it's R online. And so if I just go ahead and throw this in there, and I'll show you what it looks like here. There we go. You're actually able to do some R programming right here. But the only trouble here is that you have to copy and paste this into your editor to save your results if you want to save the results or save your work. So what I could do though, I mean, I've used this before though, where I just like go to my editor, I type in some math and some other things I want to do, paste them into here, and then I hit this execute button, and there we go. Here's my result, 35. So we're going to talk about this today though. This is what the R language looks like here, where we have the X. This is not a less than minus 10. In R, actually, how you assign variables is you use this arrow, a less than dash. And that's supposed to look like an arrow. So really, you have an arrow that points at the variable, and on the tail end of the arrow, you have the number. Now, you could still use, if you want, you can still use an equal sign, and there's nothing wrong with that. I'll bet you that I can do that here, change that up and see, let's see what I can do, and I should still get this to work. So they've changed this thing around, but you'll find that in some of the traditional textbooks that talk about R, no, stay on the page. I don't know why that just happened here. In the traditional textbooks that talk about R, like for instance in the textbook that we're using for this class here, these are traditional programmers, so they write traditional textbooks. They use this kind of notation here, the less than dash, to signify that you're actually assigning some value to something. And this is from old computer science, in other words. You're using this arrow here to signify that this Z or this X or this Y is actually receiving the value or being assigned the value of 10. And so that's, I guess, some notation that they used before. This concatenation line here, that's just your average print statement. I could put, like, for instance, I can change things around, for instance. Now, I do expect you, though, to have some fun with this here and kind of just play around with this code here. Remember, you're not going to break anything here. Nothing. You can't cause any real damage to your program here. We're going to be updating things all the time here, and so you really can't do any damage here. And so spend some time here just to do what you can do. Let me go back to the slides here for a second here. I want to just look at these websites here and just give you an idea about where you're supposed to go. In fact, if you want, I can get you started with installing some of this stuff here, so that you can listen here, and then on your computer should be installing things. Now, I went to my slides here, and I just put in this cran.rstudio.com. Oops, where am I? There we are. So download and install R. The thing that you first see here is your R programming language here. So I'm using a Mac machine here, so I click on R for programming Mac, or R for Mac. If you were using Linux or Windows, then you'd click on the appropriate links here. And then once you get to this thing here, then you have these packages down here. For instance, in Mac, you have these PKG files, which you can. They're compressed files here. It's like a suitcase filled with stuff, and the suitcase has been squashed together here, so all the files are inside there. But when you click on this thing here, your computer should know what to do with them. Like, I think if you go to Windows, do they give you a zip file? Is that what they give you? Install R for the first time. You have to read some things here. There we go. So you're clicking on this up here, this file. Download R 402 for Windows. And I think that's going to be, yeah. You can see, this is going to try and ask you, you don't see it here. It's an exe file. It's an executable file. You can't see that here when I'm trying to download this. So first of all, start with downloading the R programming language. Then once that works, you should get the all clear from the installation. Then what you want to do is you want to go to the other link here, which is the rStudio link, and then go to another page here. I just leave everything open, if you wouldn't mind. And then go to download, and you should find, there we go. You find this download rStudio page here. Now, the rStudio isn't just used by students; it's used by industries too, and they make industries pay for it. In fact, that's how they encourage. Well, that's how they make people. That's how they pay for their research, I guess, that develops rStudio. And so they have all these other types of, they have these pay services here. This is like this, or actually it's this one here. The desktop, which is $995 per year, or they have the rStudio Server Pro, which is nearly $5,000 a year. Now, these are for people who use rStudio professionally. That means that if you're paid for your work, and you're working for a company, and you're using this as rStudio to do your work, then you'd have to pay for it. But since we are academics, we just click on this download button here, and in this case, it seems that it's recognized that I'm using a Mac machine here. If I were using Windows, it would tell me what it is, but it's basically asking me to download the version for my Mac. Now, this could take some time to download. This is 150 megabytes here. I know that doesn't sound like very much, but in my experience, though, downloading from these kinds of websites in the middle of the day does take time, though, because I'm not the only one downloading something. So try and download those things. You can try it right now if you want, and then if you have any trouble, let me know. But otherwise, I think that you should be. I think it's fairly painless to install this. And on my machine, for instance, I've installed this, and so I can show you what it looks like. And so this is on my machine here. I have my rStudio set up here. In fact, you can hardly see this. I have to change my size. I can change the size somehow. How do I do this here? I'm looking to see how I can change the setting here, so you can see what I'm talking about. Maybe that works. Can I apply this? Well, it's a little. It's kind of big. I can change the zoom here, and so maybe, for instance, that's good enough. Maybe that's good enough. Can you see that? Yeah. So anyway, but what I'm saying is you can install this on your own machine, and it works quite well. And I can type in, for instance, 3 plus 4, and I can get an answer that comes up on the page here. But don't worry about this just yet, though. Just concentrate on getting this thing installed, and then we'll start working on some of the code here, and we'll see what we can do. Right, so I'm going to go back now to the slides, if I can find them, and we will start there. By the way, are there any questions at all that may be happening? If you have any questions, please just unmute your microphone and just say something, and I'd be glad to take your questions. Alex. Yes, so the question is, why is there a difference between, what is the difference between the server, or the server here, and the desktop? So actually, the server is very much like the Docker version of rStudio. So in some ways, you can say that the server, if you install the Docker version, you're using the server. The server is more of it's a web page driven way of using rStudio, which works out quite well. But sometimes, though, if you're wanting to automate something and you actually want to have, maybe you need to load programs quickly and you don't want to use a web browser for this, then maybe you'd rather the standalone program there. But I would recommend just using the rStudio desktop application, which is just like any other application you'd have installed on your machine. The server you can run, and it uses your browser. I mean, the functionality for in this class, what we'd use would be about the same, I would say. You can choose whichever one you want. But for me, though, I mean, I'm running rStudio as a server in a sense, using the Docker Studio or the Docker container, and so that's for me close enough. I'm already. One thing I will say though is that when you're using the server or Docker, you have to fire up your web browser to interact with rStudio. Now, if you have a memory problem here, I don't mean a memory problem, but if you're running out of memory in your computer, then maybe you'd like to have all that memory allocated for your Docker application and not have to spend memory on running a browser. Every time you open up each time you open up a browser tab, like here, for instance, that works out to be about, I think it's between 200 and 300 megabytes of memory that's just gone. It's just gone, even if there's nothing on the website. Even if it's just an empty tab, it's like 200, 200 megabytes just gone. And so if you have a bunch of tabs open, if you're using your browser and things like that, and memory is becoming really rare on your machine here, then maybe having the standalone app and then closing your browser would be a better option. But Alex, that's a really good question. I think it works out. I think it depends on the applications that you'd like to use. Maybe, for instance, if you're installing this, you could use a server on a machine that's actually that has terminals that people would use. So you don't actually want to have anything installed on each machine, but you want people, say, in like a library setting where you have a whole bunch of terminals scattered throughout the building. You don't want to have them. You don't want to have to maintain one copy of the program for each computer, but rather each computer would log into the server, and that's the one copy that you maintain. So maybe it's a maintenance issue. Are there any other questions? Everybody okay? Okay. Well, I'm going to move on now. Please try and install your code and see what you can do. And I think that hopefully by the end of today, if your code is working, then that'll be terrific. Otherwise, if it isn't, then let me know, and I'll see what I can do to help. Okay, so this is rStudio here. This is you're going to see a screen that looks kind of like this. This is in fact, this is an older version here, but it's going to be the graphics were always the same here. On the left, you have the place where you actually write code. On the right, you have your variables, and then you have in this red box here, you have like kind of what I call the user screen, and the user screen will have things like help, or it'll show you, it interacts with you in some way. It'll show you the plots or some other things that you might be doing here. But in this case, though, I will say that rStatistic, though, or rStudio and rStatistic here, but rStudio does have a very extensive level of help, like online help here. So getting back to my thing here, I can type in help. We've seen the command here, cat. In fact, I don't know why I can't. Oh no, there we are, cat. So if I type in cat, hello, it's a print statement. So if I'm thinking, well, what does cat mean? Is that like meow, meow, cat? No, it's a concatenation. I can type in a question mark followed by the word cat, and then on the other side, hopefully you can see this, you can. On the other side of the screen here, on the user screen, you'll have like this online help, which is over here, which discusses what this thing is. And so it's actually very, very nice. Now in Python, you don't necessarily have that unless you're using a Python editor here, but since we're going to be using this all the time, I mean, the help just kind of comes together here. But what I particularly like about this help is, in most cases, if I go down to the very, very bottom here, I have all the information about the arguments, like how I can use this program or how I can use this function. But going down to the bottom here, you have examples, which I think that as you mature in computer science, I think that the actual arguments themselves can be understood by looking at the example. And so, for instance, here we're just kind of using some code here, creating some interesting things here, but then we're actually writing this. We're using cat here to output the results. And so that may not seem like much, but at like 3 in the morning when you're working on your R code here and things that just aren't working, if you go back over here and you just have you put a question mark in front of the command that you're trying to work with here, and you see this help over here, sometimes everything just falls into place. It's like suddenly you understand everything. It's like, ah, this is terrific. It's just wonderful. So that is a great thing, I think, about RStudio and R, is that you have this online help. Now, even if you're using R without RStudio, you could still type in !cat, and it would take you to a page, like a manual page, just like where you have the same information here. So it's actually quite good. Now, let's actually start talking about RStudio here. So the oops, sorry about that. We're going to talk about variable names here. Now, variables are actually a very big piece of writing code here. Variables are places where they're like places in memory where you store some value, a string or number or a floating point or something, an array or maybe even a whole an entire set of data. But you have data, or you create basically words which are going to be used as bookmarks to memory places, and those memory places contain the information. So we call those variables, and variables, just think of variables as being associated with some number here. So you have in different books here, something I've noticed here, you have different ways of actually writing the variables here. Now I've noticed that, for instance, in this book, you have, like, for instance, this might be a variable that stores the value of height, or maybe another variable that stores length and width. But in the book, they use these underscores to separate the words here. And so you make your variables as understanding as possible here. You don't want you won't just put x. X is equal to 1.81 or something. Because when you look at your code later on, you want to think, well, why did I call it x? What is x supposed to be here? And so typically when you come up with a variable name, though, you want to have something that's meaningful, so that you look at this and think, oh yes, right, that's the height of this cube that I'm trying to calculate the volume of. And so in the book, they use this underscore here. In Java textbooks here, they use something else called, I think it's camel case, where you don't have that. Anyway, we'll talk about some of these things here. Then we have, for instance, we have mathematics here, where we're going to have, like, for instance, you can just add some, I mean, your R statistic actually works as a calculator. So let's just try some of this stuff out here and see what we can do. So if I go back to my thing over here, I can type in, like, for instance, 1 plus 1, oops, sorry. I can have, does pi exist? Oops, not pi here. I guess that doesn't work here. So I'll say that P is equal to 3.14. So I'm actually creating, I'll call this pi value. So pi value, I've just created pi. I've just made some pi. But you can see I have to find this value down here, 3.14. But also, though, if I go up to the upper right-hand side here, under global environment, you see that my value, pi value, 3.14, is up there. Now that helps you to kind of follow the data here. If you're trying to write code here, it helps you to follow the variables. So now I can say, okay, well, let's see what is pi value. And I'll add another number to it. Let's say I'll add 2 to it. So what this is doing is it says, okay, pi value, I know what that value is. That value is 3.14. In fact, I can just type in pi value, and it says 3.14. That means that this is actually, the computer recognizes pi value as 3.14, and then when I add 2 to it, it's going to come up with 3.14 plus 2, which is 5.14. And so that's what I'm talking about with these variables here. It's nothing more complicated than that. So now this is you can do more complicated math here. Like, for instance, this whole body of text here is actually an equation. If I go ahead and dump this in and push enter, it calculates the whole thing for me. So really, it's like you're running it on a calculator. But this also is smart because it remembers the orders of operations. Where, for instance, you're hitting the multiplication, then the division, then the addition, then the subtraction, going from left to right. And that's how this whole thing works here. It's just putting everything together. So what I'm saying though is as long as your numbers are correct, rStudio should be able to do your all your math homework for you here. This is getting back to the variable names here. So for instance, you can use these. You can use like these heights. It's like how you can use camel case. Like for instance, camel case tends to be used by Java. Period case could also be used by Java, I guess here. But I think that's typically when I code here, I might use this. Actually, I might use more Java. I think that when I first saw some of my variables, I was taught in a Java sense here, and so I tend to write my variables as Java in this camel case here. But it doesn't really matter. What I'm saying is that choose a convention that makes you that works well for you, but also though choose something that perhaps people from your area would also use, so that you can eventually share code and they don't get lost in how you defined everything here. This is what we discussed before: assigning variables. I can assign a variable with this equals sign, or equally I could assign a value with this less than minus, or this arrow. In other words, it's a rough arrow here. That's basically what it is. It's an arrow x and 1 with the arrow pointing at x. But you'll find that, for instance, you can still use your equal signs here, and that's just a new piece of code that they put into an old program. So we can try that if you want. You can just go ahead and run these things, and if you assign x to 1 and y to 3, and then you add x plus y, you get 4. And in fact, on this big blue box above here, you can see the output. Now, x and y. This goes back to my original idea here that you want to make something. You want to make something easy to remember, or something that helps your code here, helps you to follow your code. Having the variable x and the variable y isn't very helpful in determining what those values actually mean. And so you might consider using something a little more descriptive. Like, for instance, I know this isn't any better, but my num and my other num might be more descriptive. You could change them even to be even more descriptive here, but they become variables that help you to actually code. So you might say, for instance, my number from the I don't know, something. My number underscore protein or something, my number of proteins or something like that. But something that helps you to remember what these variables actually mean, because otherwise you're looking at these things later on thinking, what does this variable even mean? Why did I write this? Why do I need x in my equation here? What is x? One thing I will say though is I want to show you how to use negative numbers here, because I think that many students, when they first see this arrow here, they assume that this is some kind of logistics or a logical thing here where it's saying my number is less than minus 2. That's not what's going on here. Remember, this is all, there's no spaces between this arrow and this less than and the hyphen here. So if you want to have if you want to assign a value to a negative number here, you need a space between here. I know this sounds very, very basic here, but believe me, it happens to everybody where we're thinking, why is this not working? Why am I not able to assign my negative values here? Well, you're changing your declarations around by having this negative, by thinking that this is not an arrow, but this is more of the less than negative sign here. What I'm trying to say though is that when you're assigning things here, just keep this all together, have a space, and then have your value after that. Now, so let's go ahead and just try something here. So we can do an experiment here where we're working with the Pythagorean theorem, where, for instance, we're looking to see whether we can solve this equation. And you can see that first of all, I'm assigning the value a to 3, which you can see in your. You can see this here. You can see this on the first leg, and on the longer leg, which is b, I can assign that here. Whoops. And then, if I wanted to figure out what c is equal to here, well, we know from the Pythagorean theorem, the hypotenuse is equal to the square root of a squared plus b squared. And so this is actually a piece of code that I can just put in. So let's go ahead and see what that looks like now. I know that you've probably seen the Pythagorean theorem hundreds and hundreds of times here. So you're probably thinking, why do I care about this now? Well, you might. So let's say 3, and then I'll have b is going to be equal to, now this is, I know these variable names. I just got done telling you to have meaningful variable names, and these are not very meaningful at all, but I think that maybe this is okay. And then I'm going to say that c is now going to be equal to the square root, and then this is actually a function here. In fact, I'll show you something. I can say square root of, what's the square root of 4? It says it's 2. What's the square root of 16? It's 4. What's the square root of 225? It's 15. And so what I'm saying is you can use this to find out the square roots of numbers very easily. And so going back to here, I'm going to say that C is now equal to A, and then if I want to square something, I have to use this caret plus 2 plus B caret, oops, 2. There we go. And now C, if I just push C by itself, C is now equal to 5. So it's not the biggest it could be, but I guess it's okay. We can all read that. But what I'm saying though is that you can use R for basic back of the envelope types of calculations here, which is actually quite exciting. Anyway, there's this. Other things you can use R for are if you've taken a class where you have like logical operators here, like Boolean operators. You can work with Booleans. There's no libraries to load. All this stuff works right out of the box. You just like kind of reach in and pull everything out, and it works. So, for instance, going back to my R statistic here, I can do, for instance, let's just do like a true here. So let's say that is 3 less than 5. It's true. 3 is less than 5. However, if let's say that it's 5 less than 3, that's not true. That's false. That is a Boolean. That's Boolean math right here, where basically the result is always a binary thing. It's like it's a true or it's false. It's not a number, but it's true or false. And if you've taken my my 102 class here, the discrete structures course, we spent a lot of time talking about some interesting applications that we can use with Boolean functions here. I think that Dr. Capham right now is teaching the same class, and so he might be doing the same kind of thing too. It's very, very cool. Okay, so what else can we do here? Let's do another one here. So what about if I say that 2 plus 4 is equal to 6? Can I say that I'm going to test to see whether is 2 plus 4 really equal to 6? Is that a true test? You can see that is true. That means it does actually equal. Can I say that is 2 plus 4 not equal to 6? That's false, because 2 plus 4 is equal to 6. And so this is saying that 2 plus 4 is not equal to 6. Now, if I put, like, for instance, not equal to, let's just put 9,000 here. That is true because 2 plus 4 is certainly not equal to 1,000 or 9,000 here. And so these are what Boolean operations are all about. Now, you might use these things in your code in your algorithms, for instance. When you're running an algorithm, you might need a Boolean here that determines, you might have like a while true type operation here. And while something is always true, then you're going to keep this thing going. But otherwise, when it becomes false, then you stop your algorithm right then and there. And so in that case, you'd be using these Boolean functions here. So let's go back to the transition here and see these things here. You have these same operations here for seemingly all kinds of math. Anything you can dream of, any kind of math, you can test on here. Is 5 times 2 not equal to 11? That should be true. This is 5 times 2 is going to be 10. So 10 is not equal to 11. Let me just show you that. Actually, that's kind of an interesting little thing here. 5 times 2, is that not equal to 11? That's going to be true, because really 5 times 2 is equal to 10. So the question becomes, is 10 not equal to 11? And that's true. 10 is not equal to 11. So that's where that's all coming from. And I hope you can all see this. I can try and make this bigger if that makes it helpful. Let's see if I can do that here. Appearance, font size. Maybe I can make this 3. Oh, maybe that's better. Maybe that's better. There. Yay! Hey, cool. Make this bigger. I didn't realize I could. It was so easy. I was getting myself all geared up for some long process where I have to spend all this time working into this thing here. So I just put these things out here. These are, this is from De Morgan's laws here, and I have the links below for you to see. Truth tables and De Morgan's laws are really types of mathematics which center around the premise of Boolean logic, where, for instance, you can have false and false. Is that false? False and true. true and false, and true and true. These are, if you remember these things from your algebra courses or other courses where you've been working with Boolean logic, you may have remembered these things. But this is, you can actually run your homework, if you will, through this service here. And so let's just try that and see. Let's just say I have false. In fact, if I just have regular F, that usually means false. If I have this uppercase T here, that usually means true. So what I'm saying is that if you're looking for a variable name here, please avoid using T and F as variable names, because in R, it tends to mean true and false. But you can always just type in true if you want. Uppercase true and uppercase false. Oops. And that's the same here. So I'm going to say false and false. Oops. Is false. Is false and true. True is true and true. True. True and true is true. Anyway, there's a lot of theory that goes behind this, and this class isn't designed to discuss all that theory. But if you are interested in learning more about these truth tables and things, then that's why I'm putting these links down here. Or you can take discrete structures, where we actually spend, I think it's like 2 weeks talking about truth tables, which is actually quite exciting. I've taught that class before, and so it's actually it's a cool class to take. Another thing you look at here, for instance, is the logical nots and logical ors. Those are other things that are other pieces of code that you can look at here. So for instance, if something is true or false, then we consider the whole thing to be true, because one of them is true. If we have false or true, then again the whole thing is true because one of them is true. So as long as something in this equation here is true, then that's okay. But when both those things are false, then we say that they're false. Yeah, I don't want to say too much more about that. Then we have over here the logical not operations here. So if I put an exclamation point in front of F, then that means that it flips it around to the other thing that it could be, which is true. So for instance, if I go here, and I say that false is here. If I say that not false, then it has to be true. Or not true, it has to be false. And so you kind of see how I think you can, whether or not the math jumps out at you right now as being exciting, I think you can still see that that R can do some pretty sophisticated things with math. It's basically a program that's built around math. Now, if you wanted to do this whole thing in some other programming language, like Python, for instance, then chances are you'd have to install some packages. You could still do it, but you may have to install some packages. Whereas in R, for instance, all of this stuff seems to work right out of the box here. So now it also works with, we're going to talk about strings for a second here. It also works with strings, and so I have these two different things here. I'm going to say H and W, hello world, and then I can use this other command here called paste. And in fact, what does paste do? Why, I don't know. I'm going to look it up and see what paste does here, and I can type in question mark, P-A-S-T-E, and if I push enter, oh, here's what it does. It concatenates strings, which really means it puts strings together. It takes this string and that string, and it joins them together, and that's all it is. And then if you go down to the bottom here, you find that there are some quite exciting examples here. So let's just go ahead and try something here. So I'm going to say that my first name is going to be equal to, I'm going to assigning a line to this thing here. I'll just say that it's Sherlock. And my last name is equal to, oh, I don't know. I'm just making up names here, but Holmes. Sherlock Holmes. And if I type in, for instance, paste, I could do first name, last name. Oh, gosh, I can't see it. I'm so sorry, guys. There we go. So I have this information over here. And if I type in paste, then it should put everything together. Now, I have this other option that I can add to this thing here, too, which is called sep. And that is going to be equal to, let's say I want to put, like, for instance, something in the middle. I don't know. I'm just putting some characters in the middle here. I can put in this, I can actually say, okay, in the separation between these two things here, add the two words together, but where they join, add this separation piece here. And so I can actually add some stuff. And so we can actually make this quite exciting and add a whole bunch of stuff in the middle here, just to see what it looks like. There we go. So, I mean, right now, I know what you're thinking. Why would I ever need to use this? What could that possibly do for me right now? Well, I'll tell you. When you're using these string concatenators here, it's probably because you're wrangling your data. You probably have data which is separated by which is separated by a space, and you need a comma. You need to have a comma between those words so that you can create a CSV file or something. That's how your data is supposed to work. It's supposed to work with a comma between these pieces of information. And this is the command that you would use to add that comma between both of your things here. And so in this case, I might remove all this stuff here and put comma. In fact, I don't want last name first. Oh, sorry, I want last name first, first name last. Here I have Holmes, comma, Sherlock. Or add a space, Holmes, comma, Sherlock. And so now I'm actually able to wrangle my data. That means I can grab a string here, and I can manipulate that string and move things around, because you will need to use this when you're working with data. We will talk about this, but it's on the horizon, though. This should be on your this should be on your radar here, that when you get data from online sources and things, it usually comes as a spreadsheet, and for your particular application, sometimes you have to change things around and make it work for you. Another thing you can do are these built-in functions in R. I think that today we're just going to be talking about R. We'll actually do some analysis, I think on Thursday. But I just want to kind of give you an idea about what this thing is. And by the way, did everyone get their thing to install? Paige in the back there, did you get your thing to install? And Brian, you're all good. Okay. Everyone over there, everyone's okay? Everyone, okay. That is terrific. You have no idea. You have no idea how happy that makes me when these things are installed. When I first taught this class, the installations that they gave us on the website were not as sophisticated as they are now. And it was like, 4 to 5 times it didn't work. And so everyone's like pulling their hair out, and and it was like people were just on the edge of their sanity here, trying to get this thing to work. So good. I'm glad this all works. And if you can also try getting the Docker container to work too. Make sure that you have your Docker installed first. I'm still working on how to get the Docker on Windows working here, but I'm trying to get some answers here. I know that some of you have asked me questions in the past about how to use Docker on Windows. If you have figured that out, please let me know, or maybe write it in the Slack group here. It's for your colleagues here, because I mean, you're not the only one to have problems with Docker. So if you find something really amazing, I implore you, please add your inspiration, your insight, your wealth of knowledge to Slack about Docker, and everybody would be glad to read it, because I'm sure that we're all going through similar types of problems here. Okay, so another thing I want to talk about, though, is, for instance, this is you can use this built-in command here called sequence, or seek, and what that does is it will create a sequence from 1 to 10, or 1 to 100, whatever I say here, or from, for instance, 90 to 100 here. I'm actually able to create a sequence, which is actually kind of interesting if you think about it. Here I am. It's interesting in terms of computer science here, because here I am writing one line, but actually, obviously, in my code here, there's a for loop involved someplace. There must be a for loop, something that's going on for I equals 90 to 100, next 90 or something like that, or it's basically adding 1 to that iterator. But in this case, though, you have a lot of built-in commands here that are doing these loops for you. So you don't actually have to write code that creates the sequence. I mean, you can if you want, but you don't have to always. Now, another thing I wanted to show you was this command here called sum. Sum, I can put, like, for instance, it'll add together these two numbers that I put in here. In fact, I can find out more about these, both seek, by the question mark here, sequence generation for seek, and for sum, oops, the sum of vector elements here. So I have these two new functions here that I can use. Now, I can put them together. I can nest my functions together. So let's just say I have seek 1 to 100. Let's say I want to find out what is the sum of adding up 1 to 100. If I take 1 plus 2 plus 3 plus 4 plus 5, and so on and so forth, all the way up to 100, what is my final result? And the result is 50-50. So the thing is, though, that in a very short amount of code here, I can actually do a lot of really kind of, annoying math, I would say. I mean, if you wanted to write a program to do this, of course you can do this in a program, and there's no problem there at all. But if you wanted to write a program to do this, I'm thinking that in Python your program might be 2 or 3 lines, and you actually have to spend some time thinking about this. Whereas here, for instance, you just throw this up and it's done. And so what I'm saying is that there are many built-in commands here in R, which makes it a very sophisticated language here. Let's go even higher and just see what happens if I count up to 1,000. As a data scientist here, you should start noticing that a pattern is emerging. Now, as I was saying before, we don't know what that pattern is until we actually study the numbers and study the math. But you need to be starting to think about things that you have to do, or thinking about looking for patterns in your numbers here, because that's what you're doing here. You're running all these calculations in effort to find a pattern. And so now that I see that there's a pattern here, and the numbers that I get from these sequence summations here, the numbers have 0s and 5s in them in every case, no other numbers. That means that there's something that needs to be explained if I wanted to figure out why, how this is all working. What's the mechanism here? So as a data scientist here, when you're doing your analyses here, you're going to find that that your numbers are showing you things, patterns, trends. Something's going to be coming up. Now, you don't know what that reason is that made that happen, but you do know that something happened. And so this is your I guess your beckoning from your numbers here, your results, to go back and check to see what it is that caused this pattern to show up. Otherwise, we have no idea. We have to go back and investigate, and that's the other side of the program, or the other side of the problem. Anyway, so you have all this here. So one last thing I'm going to show you, I think we have like 2 minutes left here, is how to make a very, very basic plot here. And so let's make another sequence here. I'll say sequence from, how about 0 to, I don't know, 20, like that. Yes, sir. Oh, sorry. I assure you, you're not going to hurt my feelings if I don't switch over the slides, because I have to, I don't see what goes up there. That's why I have to keep looking up there. But please let me know. Please let me know. Alex, you have to keep me online on this one. Okay, so I'm going to make this sequence here. So sequence here, I'm going to assign x values to my sequence here. Let me just show you this. This is actually kind of interesting. So when I run this thing here, notice in the upper right that my value x vals under the global environments has shown up here, where I have it's basically an array. You see at the top there. And if I go down here and I type in x vals just by itself, I can see the numbers that came out of this thing here. These numbers were created by my sequence here. So now what I'm going to do is I'm going to plot this over here. So I'll say x vals, and I think, there we go. It just makes a plot here. So just imagine, so the numbers, or the way that these numbers are being thrown up, that's the order for the x-axis here, and then I have the y-axis, which is going to be the actual numbers themselves, I think. So actually, this would be better called as y, I think. Maybe I can change that here. It's gracious here. Anyway, I'll just call it the x values here. We'll change that later here. So I have these, so I can plot these things over here. I can change some things around here. I can change, for instance, I don't want to just have a bunch of points here, but I can actually put up a line. I think I can put up a, does this work for V or V? No, it doesn't work for V. Sometimes you can change these things. Oh, maybe I can use a star. No, it doesn't work. So I guess you have to figure out what these things are, but still you can change your plot by your code here. Now this is actually quite nice though. I mean, just one line of code here. Well, 2 lines, I guess, if you think about actually defining this x values here. But I can create this code up here. Now I can change things around even further. Let's just show you, or let's just go through. I want to plot up a sine wave here, and so I can plot sine, or I can plot, for instance, cosine, or I can plot tangent. So really, what's going on is these are all built-in functions, and these functions then collect the numbers from this variable here. Now, one thing I would like to talk about, though, just quickly, I know that we're almost out of time here, is that one thing that makes R different and sometimes a little bit hard to learn is that this value xvals is actually talking about a whole series of numbers here, not just one number. And so when you throw that value into, for instance, sine, cosine, or tangent, you're actually throwing all those numbers in a kind of an iterative process here, which is all handled by our statistic here. And so you don't actually worry about how the numbers are placed in there. As we go through here, I mean, that's basically it for today. But as we go through this, you'll see that coding in R is actually different from coding in other languages here, because your one variable actually may indicate hundreds of numbers, and you just throw that one variable into a function, and then that function is run for each of those numbers in your thing here. Anyway, that is it. We are at time here. I think almost at time here. We have 20. We have 3 more minutes to go. I don't know if I want to get too far ahead of everything. I don't know if we have any. What other slides do I have here? Yeah, so I just have some things you can try here. When we come back next time here, we're actually going to start moving into installing our first package, and then we're going to use that first package to do some pretty exciting mathematical analyses on I think it's sunspots really, isn't that here? The sunspot data. So if you know anything about astronomy here and you've been studying the sunspots, you'll see what they we'll study that data, which is actually it's an interesting thing here. When you are finished, you can exit this thing out. One thing I would like to say though is if you open up your Docker container, let me just show you how I get out of my Docker container here. I go down to the bottom, which is right here. And since this is still, my container is still open, I hit Control-C, and then all processes get the term signal, which basically means you're done.